According to the National Electrical Code, you cannot use a single 3SE cable rated at 95 amps to feed a 100 amp panel from a pedestal. The current rating of the cable must be equal to or greater than the rating of the overcurrent protective device protecting the circuit. In the provided scenario, the overcurrent protective device is the 100 amp main breaker in the panel. Therefore, you must use two 3SE cables rated at 130 amps to feed the panel. This will provide a current rating of 260 amps, which is greater than the 100 amp rating of the panel. The NEC does not allow you to move up or down to the next overcurrent device when selecting the size of a conductor. The conductor must be sized to the rating of the overcurrent protective device protecting the circuit. The reason you have not been able to locate a 3-3SE cable is because it is not a standard size. Service entrance cable is typically available in sizes from 2 American wire gauge to 10 American wire gauge, and the third number in the designation indicates the number of conductors. Therefore, 3-3SE cable would have 3 conductors, each rated at 3 American wire gauge, a configuration not typically used for residential applications. It is recommended to use two 3SE cables rated at 130 amps to feed the panel, as this meets the requirements of the NEC and ensures that the panel is properly protected. When determining the appropriate conductor size for a particular application, several factors must be taken into account. Firstly, the ampacity of the conductor must be sufficient to carry the calculated load. The calculated load is the total amount of current that the circuit is expected to carry under normal operating conditions. This includes the current drawn by all of the connected devices and appliances, as well as any future load that may be added to the circuit. Secondly, the conductor must be protected from overcurrent by an overcurrent protective device, such as a circuit breaker or fuse. The overcurrent protective device must be sized to protect the conductor from overheating and potentially causing a fire. The size of the overcurrent protective device must be equal to or less than the ampacity of the conductor. Thirdly, the conductor must be suitable for the environment in which it will be installed. For example, conductors installed in wet locations must be rated for wet locations. Conductors installed in high-temperature environments must be rated for high temperatures. Fourthly, voltage drop must be considered. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to the resistance of the conductor. Excessive voltage drop can cause appliances and equipment to operate inefficiently or not at all. The amount of voltage drop that is acceptable depends on the application. In general, voltage drop should be limited to 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the direct current constant, which represents the resistance of 1 circular mil foot of wire. For copper, K is typically 12.9 ohms, I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor in circular mils. The National Electrical Code provides tables that list the ampacity of various conductors. These tables take into account the type of conductor, the insulation rating of the conductor, and the ambient temperature. The NEC also provides guidelines for certain conductors when they are installed in certain conditions, such as when they are installed in raceways with other conductors or when they are exposed to high temperatures. When selecting a conductor, it is important to consult the NEC and follow all applicable requirements. Failure to do so can result in unsafe installations that could pose a fire hazard or other safety risks. In the scenario you presented, the use of a 3SE cable rated at 95 amps to feed a 100 amp panel would violate NEC requirements. This is because the ampacity of the conductor is less than the rating of the overcurrent protective device protecting the circuit. In this case, the overcurrent protective device is the 100 amp main breaker in the panel. The NEC requires that the ampacity of the conductor be equal to or greater than the rating of the overcurrent protective device. Therefore, you would need to use a conductor with an ampacity of at least 100 amps. You mentioned that you looked for 3-3SE cable, but couldn't find it. This is because 3-3SE cable is not a standard size. SE cable is typically available in sizes from 2 American wire gauge to 10 American wire gauge, and the third number in the designation indicates the number of conductors. Therefore, 3-3 SE cable would have 3 conductors, each rated at 3 American wire gauge. This size of cable is not typically used for residential applications. A more appropriate solution would be to use 2-3 SE cables rated at 130 amps to feed the panel. This would provide a total ampacity of 260 amps, which is more than sufficient to carry the load of the 100 amp panel. It is important to note that the NEC also requires that the neutral conductor be sized appropriately. The neutral conductor must be sized to carry the maximum unbalanced load in the circuit. The unbalanced load is the difference between the current flowing through the phase conductors and the current flowing through the neutral conductor. In most residential applications, the unbalanced load is relatively small. However, in some cases, such as when there are a large number of single-pole loads on the circuit, the unbalanced load can be significant. In these cases, the neutral conductor must be sized accordingly. In addition to the NEC requirements, it is also important to follow all local codes and regulations. Local codes may have additional requirements that are not covered by the NEC. It is always best to consult with a qualified electrician to ensure that your electrical installation is safe and compliant with all applicable codes. To reiterate, when selecting a conductor for an electrical installation, it is important to consider the following: firstly, the ampacity of the conductor; secondly, the overcurrent protection; thirdly, the suitability for the environment; fourthly, the voltage drop; and fifthly, the local codes and regulations. By following these guidelines, you can ensure that your electrical installation is safe and compliant with all applicable codes. The information provided is intended for general guidance only and should not be considered a substitute for professional advice from a qualified electrician. Always consult with a qualified electrician before performing any electrical work. Consider the ambient temperature when selecting conductors. Higher temperatures reduce conductor ampacity. Refer to NEC Table 310.15, which provides ampacity correction factors based on temperature. Using the wrong size or type of wire can lead to overheating, insulation breakdown, and potentially fires. Always double-check your wire selection with an electrician or qualified professional. When running multiple conductors in a conduit or cable, you need to direct the ampacity of the conductors. This is because the heat generated by the conductors cannot dissipate as easily when they are bundled together. Refer to NEC Table 310.15 cone for directing factors. Properly grounding and bonding the electrical system is crucial for safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the overcurrent protective device and prevent electrical shock. Bonding ensures that all metal parts of the electrical system are at the same potential, which also helps to prevent electrical shock. Always use approved fittings and connectors for all electrical connections. This will ensure a secure and reliable connection. Never splice wires outside of an approved junction box. Splices that are not properly enclosed can be a fire hazard. Protect cables and conductors from physical damage. Run cables through conduit or use other means to protect them from being cut, crushed, or otherwise damaged. Label all circuits clearly. This will help you to identify the correct circuit when you need to work on the electrical system. Use a voltage tester to verify that a circuit is energized before working on it. This will help to prevent electrical shock. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Always disconnect power at the main breaker before working on any electrical circuits. Wear appropriate personal protective equipment, such as safety glasses and gloves. Work in a well-lit area. Avoid working on electrical systems in wet conditions. Be aware of your surroundings and avoid contact with any conductive materials. If you experience an electrical shock, seek medical attention immediately. Understanding conductor ampacity is a fundamental aspect of electrical safety and code compliance. It involves not only selecting the right size conductor for a given load, but also accounting for various environmental and installation factors that can affect the conductor's ability to safely carry current. Firstly, the National Electrical Code provides detailed tables and guidelines for determining conductor ampacity based on factors such as conductor material, insulation type, and ambient temperature. These tables are essential resources for electrical professionals and should be consulted whenever selecting conductors for a specific application. Secondly, conductor ampacity is directly related to the conductor's ability to dissipate heat. When a conductor carries current, it generates heat due to its resistance. If the heat generated exceeds the conductor's ability to dissipate it, the conductor's temperature will rise, potentially damaging the insulation and creating a fire hazard. Thirdly, the ampacity ratings provided in the NEC tables are based on specific installation conditions, such as the conductor being installed in free air or in a raceway. If the actual installation conditions differ from those assumed in the tables, the conductor's ampacity must be adjusted accordingly. Fourthly, ambient temperature plays a significant role in conductor ampacity. Higher ambient temperatures reduce the conductor's ability to dissipate heat, which in turn reduces its ampacity. The NEC provides correction factors for adjusting ampacity based on ambient temperature. Fifthly, the number of conductors bundled together in a raceway or cable also affects ampacity. When multiple conductors are bundled together, they generate more heat than a single conductor, which reduces their overall ampacity. The NEC provides directing factors for adjusting ampacity based on the number of conductors bundled together. Sixthly, voltage drop is another important consideration when selecting conductors. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to operate inefficiently or not at all. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Seventhly, when selecting conductors for specific applications, it's crucial to consider the type of load being served. For example, motor circuits require conductors with higher ampacity to handle the inrush current that occurs when the motor starts. Eighthly, it's also important to consider the type of insulation used on the conductor. Different insulation types have different temperature ratings, which affect their ampacity. The NEC specifies the allowable temperature ratings for various insulation types. Ninthly, the size and type of overcurrent protection device, such as a circuit breaker or fuse, must also be considered when selecting conductors. The overcurrent protection device must be sized to protect the conductor from overloads and short circuits. Tenthly, local codes and regulations may have additional requirements for conductor ampacity. It's essential to consult with local authorities to ensure compliance with all applicable codes. The information provided is intended for general guidance only and should not be considered a substitute for professional advice from a qualified electrician. Always consult with a qualified electrician before performing any electrical work. The use of 2-3 SC cables each rated at 130 amps is a practical approach to ensure you have sufficient ampacity for the 100 amp panel. This provides a total capacity of 260 amps, well above the panel's rating, and it utilizes readily available cable sizes. Remember to always consult local electrical codes and a qualified electrician for specific requirements in your area. These professionals can provide tailored guidance based on your unique situation and ensure the safety and compliance of your electrical installation.